Hello students, welcome to the class, and today we will discuss about properties of ionic compounds. First I'll show you a video. In that video I have summarized everything, like whatever things I have seen in the video I have put all, like how it works and what is the conductivity and about everything about the structure of ionic compounds. And after that I will give you the demonstration how to write ionic compounds and some examples of ionic compounds, so that you can understand better. Okay, and at the end I have added one song for you so that you can at least listen the song, so that you will get to know about the fun after studies, right? It is not about taking studies as a boredom or a burden every time, you need to create it something more and new, right? So let's start the class.
Compounds do not just exist in a laboratory or in your chemistry homework. Sodium chloride is regular table salt. Sodium fluoride is added to some toothpastes to help strengthen tooth enamel. Ammonium nitrate can be used to fertilize plants. Although their real-life applications are very different, they share a few key properties. In this lesson, we will learn about the properties of ionic compounds. These ionic compounds have very high melting points and are brittle because of their 3D giant ionic lattice structure. Ionic compounds. These ionic compounds have very high melting points and are brittle because of their 3D giant ionic lattice structure. The strong electrostatic attractions holding the 3D lattice structure in place mean that a lot of energy is required to overcome these attractions. When we apply a force, it breaks the regular repeating pattern of oppositely charged ions, causing ions with like charges to come close to one another. The ensuing repulsion breaks the lattice structure. Sodium chloride, sodium fluoride, and ammonium nitrate can all dissolve in water, as we know. Or else we wouldn't be able to flavor our soups, brush our teeth, or fertilize our plants. Most ionic compounds are soluble in water. In water, an ionic compound can dissociate into its ions. So when we dissolve sodium chloride, it will dissociate into sodium and chloride ions. These ions become stabilized in water due to the polar nature of water. As you can see, the sodium ions are stabilized by the negative dipole of water, and the chloride ions are stabilized by the positive dipoles of water. This solvation stabilizes the free-floating ions. An ionic compound dissolved in water. As you can see, the sodium ions are stabilized by the negative dipole of water, and the chloride ions are stabilized by the positive dipoles of water. This solvation stabilizes the free-floating ions. An ionic compound dissolved in water can conduct electricity. This is another key property of ionic compounds. This is made possible due to the presence of free-floating ions. We can dissolve copper 2 sulfate in water in a beaker. Add a few drops of sulfuric acid. Place a strip of copper and a strip of zinc into the solution. These will act as electrodes. Using 2 alligator clips, connect one strip to one end of the mini light bulb and another strip to the other end to complete the circuit. You will see that the light bulb lights up. Hence, the solution conducts electricity. Following on the same idea, molten ionic compounds can also conduct electricity. The lattice structure is broken at high temperatures, and so the ions become free-floating. In summary, ionic compounds have high melting points, are brittle, and can conduct electricity when dissolved in water or molten due to the presence of free-floating ions.
We'll write some examples of Ionic compounds. So students, how do we write ionic compounds? We have studied in chapter 3, class 9th, right? First of all, we have to mention what? Symbol. Then we have to mention the charge. We already have studied a lot of things, about ionic compounds. The first ionic compound we have studied about NaCl, right? So let's say, let me use another marker. I will write sodium, and then what was the next one? Cl, and we know what is the valency. Students, you have to learn the valency, and if you don't remember the valency, you have to remember the atomic numbers, and if you don't remember the atomic numbers, then you have to do it. There is no other substitute. So this is 1 plus charge and this is 1 minus charge. See students, we don't mention charges, but we have mentioned charges for your knowledge, right? So if you just cross them up, and what you will get, see, they will nullify each other as +1 and -1. You see, the valency of chlorine is 1 and sodium's valency is 1. So the symbol we will get will be is NaCl. Isn't it easy? Next ionic compound, magnesium. Symbol of magnesium is, isn't it easy? Next ionic compound, magnesium. Symbol of magnesium is Mg, magnesium chloride, Cl. Okay, and what is the valency of magnesium? How many electrons it required to complete its outermost shell? 6. So what will the valency? 2. Because 2 already having in the outermost shell. So 2. I will not mention the charge now. Okay, chlorine as usual 1. If you cross multiply these, or you can put the cross mark on it so that you can show that yes, magnesium you're crossing with 1 and chlorine you're crossing with 2, then what the formula you will get? You get magnesium chloride. Right, 1 we don't mention here, right? We get magnesium chloride. So is it so simple, right? We will take another ionic compound again. Take this time calcium oxide. Calcium oxide. So calcium oxide. The symbol of calcium is C and oxygen symbol is O. Now we'll put the charge. Calcium. What is the valency of calcium? It is 2 plus and oxygen 2 minus. You will get to know this if you will learn it, because in 9th class, I remember, I think page number 32, it is mentioned there, 32 or 34. It's page number 37. So there you will get it. Calcium oxide. So calcium oxide. The symbol of calcium is C and oxygen symbol is O. Now we'll put the charge. Calcium, what is the valency of calcium? It is 2 plus and oxygen 2 minus. You will get to know this if you will learn it, because in 9th class, I remember, I think page number 32, it is mentioned there, 32 or 34. It's page number 37. So there you will get it. Again, you can just cross it to each other and then you will get, see, they both will nullify each other as both are having, see, positive and negative signs. So what you will get, the symbol you will get will be calcium oxide. That's simple. We get this ionic compound as we have understood the properties also today, and now we are learning how to write these ionic compounds. Similarly, we will write about magnesium oxide. Magnesium oxide symbol Mg again, oxygen, and we know their valencies already because we practice. Even if I don't practice, then I will also forget. We need to practice again and again the same thing. So if you will cross it, what you will get? Obviously, they will nullify each other because I have not mentioned the charges, but they are having charges which you are not supposed to write here. So students, I hope you understood how to write the ionic compounds and what are the features of ionic compounds. So students, my motive to play this song for you so that you can encourage towards your learning process, right? At least you can wrap this and then maybe you will able to understand the concept.
Y'all know about bonding, right?
Bond ionically.
Let's go. Bonds occur naturally. Spectrum covalent to ionically. Dependent on electronegativity. Covalent only if they're shared evenly. Big diff, it's ionic. Bigger than 2. One atom pulls harder. Pull, pull. A greedy atom's gonna hog it. No. A greedy atom's gonna charge it. I took an electron, now I'm negative. When it comes to electrons, I'm competitive. Cause my nucleus is really quite aggressive. Fight me. So you had to give, now you're positive. Yeah. These electrons control our reactivity. Trying to lose, gain, share to get stability. I steal electron to fill up my outer ring. I'm not a thief, but for ease I'm really greedy. If I steal from you, you can still be happy. You don't even need it really, you got one too many. Now we're both charged, but complementary. Won't you bond with me? I mean ionically. Bonds occur naturally. Spectrum covalent to ionically. Dependent on electronegativity. Covalent only if they're shared evenly. Big diff, it's ionic. Bigger than 2. One atom pulls harder. Pull, pull, pull. A greedy atom's gonna hog it. No. A greedy atom's gonna charge it. Ionic.
Sodium chloride gets salty when they bonded. Bonded both elements does a noble gases column. Noble chlorine has 7 valence. Stop and check the table. Check it. Sodium has 1. If it loses it more stable. Bad. Bit, bait, take, little bait. Sodium chloride gets salty when they bonded. Bonded both elements does a noble gases column. Noble chlorine has 7 valence. Stop and check the table. Check it. Sodium has 1. If it loses it more stable. Bad. Bit, bait, take, little bait. But electron. Bang. Chlorine wants more every time you can bet
That's
on.
me.
Electron charge is negative. Moves over like it's buzz. Both full valence, but they charge minus plus. These charges are on track to start bonding when they act. Plus and minus form ionic bonds. That's all it is what happened. Hey.
Unless we're disrupt with its partial charge stuff.
Ions separate and get dissolved more.
Let's go. Bonds occur naturally. Spectrum covalent to ionically. Dependent on electronegativity. Covalent only if they're shared evenly. Big diff, it's ionic. Bigger than 2. One atom pulls harder. Pull, pull.